Audio Jungle. Audio Jungle. Audio Jungle.
Hello, our subject is Environmental Instrumentation, Unit 4, Air Pollution. In last session, I have discussed about what is pollutant, right, and importance about pollutant, okay, and what is air pollution, how to affect pollution to environment, okay. So in today's session, I discussed about types of pollutant, okay, and we are measuring different pollutants. So let's see pollutant. Pollutants are elements, molecules and particles involved in pollution. Pollutants can be introduced into the environment in many ways. Number one, natural. For example, dust, smoke, forest fire, etc. These are natural pollutants. Second, human and man-made, right? For example, burning process, okay, and mining process, spray of chemicals, fertilizers, okay. So these are human or man-made pollutants. Types of pollutants. Number one, primary pollutants. Okay, in primary pollutants emitted directly into the environment. Next is secondary pollutants. That is the primary pollutants interact with other component, external factors. Okay, so these are secondary pollutants. Primary pollutants divided in three parts. Number one, mobile, right? Due to vehicle create pollution. So this is mobile pollutant. Then next is stationary. Due to mill, right, and factory through create pollutants. Then natural. Okay. So here we have discussed about different types of pollutants, right? Primary and secondary. In primary, again divided in three parts. Okay, mobile, stationary, and natural. And due to these pollutants, create carbon dioxide, nitrogen dioxide, sulfur dioxide, right? So these types of pollutants are created, right? VOC and mercury. Okay. Next question. Explain the measurement of technique for NOx. Okay. So here we are discussing about how to measure NOx, right? Because in earlier I have told you there are many types of pollutants are available in environment, CO2, NO2 and SO2. So these pollutants, how to measure? Okay, so sometimes in GTU question can be asked, explain the measurement techniques for NOx. A chemiluminescence detector CLD uses several chemical conversion techniques that take advantages of NO and NO2 chemical reactions that emit light as a part of the process. Okay, so here we are using chemiluminescence detector CLD. Sometimes in MCQ question can be asked what is a full form of CLD. Okay, so in this process we are converting NO to NO2, right? So here chemiluminescence is different from fluorescence, right? Here we are using chemiluminescence detector for measurement of nitrogen oxide. Okay, so Chemiluminescence is different from fluorescence in that the light produced steam from a chemical reaction rather than by the of absorption of photons by molecules. CNT analyzers use a thermally stabilized photodiode. CLT analyzer use a thermally stabilized photodiode is detect or measure the intensity of light that produced by reaction of nitrogen oxide with ozone. So here nitrogen oxide react with ozone. So we get NO2 at excited state plus oxygen, okay, due to chemical reactions, okay. So NO2 star is in an energy state that it does not NO2 star is in an energy state and that it does not to stay in it then quickly drop to the more stable ground state. In the process emits chemiluminescence light. Okay, so here excited state not stable there more time. Okay, and here NO2 star do chemical process, right, and emit chemiluminescence light and we get NO2 star NO2 plus Hb. Okay, as the photon emitted from the reaction fall upon the photodiode, a low DC current generated which is immediately amplified to reduce the noise adding. Right? So here, first we are converting NO to NO2, right? Nitrogen oxide to nitrogen dioxide. When nitrogen oxide react with ozone, then we get nitrogen dioxide plus oxygen. Okay. Then after, nitrogen dioxide is an excited state, right? Then emit chemiluminescence light and we get nitrogen dioxide. Okay. So here photon emitted from the reaction fall upon photon diode and low DC current generated which is immediately amplified to reduce noise. Right? Next, noise adding to the signal. The intensity of the chemiluminescence light is directly proportional to the concentration of the no molecules in the gas steam that were converted to NO2 by the reaction with up to 100% concentration. Okay, so here we told that intensity of the chemiluminescent light, right? Here we know chemiluminescence light emit, right? When NO2 go excited state to ground state. So that chemiluminescent light is directly proportional to the concentration of the no molecules in the gas steam. Okay, so here we are converted to NO2 by reaction up to 100% concentration. So first step is that when run in NOx mode, So first step, nitrogen oxide react with ozone, right? Then we get in second step NO2, right? Then step 3, NO2 plus NO, and we get NOx. So due to this process, right, here we are using chemiluminescence detector. So due to this process, we are measure NOx, right? And we know that NO2, CO2 and SO2 are pollutants. So we are using different processes, and different processes through we can measure NOx, carbon monoxide and sulfur dioxide. Okay. Thank you for watching video.